is equal to 1. Show that f of 1 equals f of negative 1. But show that there does not exist a c inside the interval -1 to 1 such that f prime of c is equal to 0. Is that what they wanted me to do?
Yeah.
And why does this not contradict Rolle's theorem? Well, first of all, Rolle's theorem will have no guarantees on this particular situation. Let's see why. What is f prime?
Negative 2/3.
Minus 2/3 x to the minus 1/3, so minus 2 over 3 cube roots x. Well, notice f prime does not exist at x equals 0, which is inside the interval -1 to 1. So in other words, f prime is not differentiable there's a big word, differentiable. Not differentiable on the interval, -1 to 1. Therefore, the conditions of Rolle's theorem are violated and nobody expects its conclusions to be true. Well, there's a couple other things they wanted me to show, though. They wanted me to show that f of 1 is equal to f of negative 1. Is that easy or tough? I hope so. I hope it's easy. F of 1 is 1 minus 1 to the 2/3, which is 1 minus 1, which is 0. F of negative 1 is 1 minus negative 1 to the 2/3, which is 1 minus the cube root of negative 1, but then squared. So that's 1 minus negative 1 squared, which is 1 minus 1, which is also 0. So the y values are equal at the endpoints. The function is continuous on the interval, but it's not differentiable on the interval. So we don't expect Rolle's theorem to be the case. But that isn't enough. They want me to actually show that there's no place in that interval where the derivative is 0. So let's set the derivative equal to 0 and see where it is equal to 0. If I let f prime equal 0, that means minus 2 over 3 cube roots of x is equal to 0, and that has no solution. Why not?
Negative 2 equals 0.
A fraction is 0 when its numerator is equal to 0. When is that numerator equal to 0? Never. It's negative 2. Negative 2 is never equal to 0. I hope. Questions? 7. Use the graph.